Hello and welcome to the FlowReactor variables and Blackboards video. In this video we are going to learn how we can make use of local and global Blackboards, as well as how to use the override feature for scene-specific objects. So let's create a new graph and name it variables and Blackboards. Double-click on the graph. In FlowReactor, every graph can have local or global Blackboards assigned. You can see all assigned Blackboards by going to the Properties window and select Blackboards at the top. In FlowReactor we can have two types of Blackboards, local and global Blackboards. A local Blackboard stores variables locally to the graph. No other graph can have access to it. Additionally, variables in a local Blackboard can be overridden. This will allow you to assign scene-specific objects to the variable. A global Blackboard is a separate scriptable object or asset file which can be assigned to multiple graphs. So variables stored in a global Blackboard are global and can be accessed by other graphs. Now let's create a simple debug log node. When expanding this node, we can see that this node has a log variable. We can now connect this log variable with a local Blackboard variable. For this, we simply click on the input field, then we can select Connect to Blackboard. A new pop-up shows up. Here we first have to create a new local Blackboard. Then we can simply type in the name of our new variable. Click on Create New Variable. FlowReactor now automatically creates a new Blackboard variable with the correct type and connects it directly to the local debug log variable. The variable in the local Blackboard is now highlighted. This means that it is connected to the actual selected node. You can also click on the link icon next to the variable field to see all nodes which are connected to this variable. This can be quite handy to get an overview of which variables in a Blackboard are actually being used in the graph. Let's quickly connect the output of our debug log node with a new wait node. Connect the wait node output back to the debug log node. Let's connect the delay variable with a new Blackboard variable. Set the delay to 1 second and assign the graph to an empty game object in the scene. Great. We can now expose our variables message and delay to the scene so that we can change them on the assigned FlowReactor component. Simply click on the toggle field in the local Blackboard. As you can see, they are now showing up on the FlowReactor component with their default value. Once exposed, we can now, specifically for this FlowReactor component, override the values. Meaning that if we had multiple FlowReactor components in the scene with the same graph, each graph could run with different override values. This is a great way for creating reusable systems with different values. Let's try it out and run our scene. As you can see, on every second our graph shows a log message. We can now change the delay and the message values on the FlowReactor component. There's one important thing to note when working with FlowReactor and using scene objects, like game objects which are only in the scene. You can't directly reference a scene object on a FlowReactor game object variable field because a graph and also Blackboards are scriptable objects and therefore asset files which are global in your project. So that's why you have the possibility to use the override feature for scene-specific objects. Now let's have a quick look at global Blackboards. There are several ways for creating a global Blackboard, either by clicking on the Create New Global Blackboard button inside of the graph, or by selecting the Create New Blackboard option in the Create FlowReactor context menu. As you can see, a global Blackboard is a separate asset file. You can then assign this asset file to any graph you like. So let's quickly assign the newly created Blackboard to our graph by simply dragging it to the Blackboard property window here. Now we are going to add a new GameObject variable by clicking on the GameObject Quick Select button. This will store our prefab. Let's quickly create one by creating a new cube in the scene and dragging it into our project. Now assign the cube prefab to the Blackboard GameObject variable. Add a new onStart node and connect it with a random inside unit circle node. This node returns a random point inside of a circle with a specified radius. We will use this random point as our spawn point. Next, connect the output with a new instantiate node, and from this output, connect it with a repeat node. Then, connect the output of the repeat back to the random inside unit circle node. Now let's connect some variables. First, create a new vector3 variable in the local Blackboard and name it spawn position. Add two integer variables and call the first one spawn count and the second spawn radius. We can now connect the spawn position variable to the random inside unit node's setVector3 variable by simply dragging it. Let's also connect the radius to the radius of the node. Now, as you might have noticed, we've just connected an integer value with a float value. This is possible with FlowReactor as it handles the conversion automatically for us. This also works with other variable types like GameObject to audio source, for example. In this case, FlowReactor will automatically get the audio source component assigned to the GameObject. Back to our graph, let's open the instantiation node and assign the prefab variable from the global Blackboard to the prefab value. Connect the spawn point variable to the spawn point vector variable. Add the spawn count variable to the repeat count variable on the repeat node. Great. Let's quickly expose the spawn count and radius variable to our scene, so we can change the value directly on the FlowReactor component. Alright, so let's run our scene and see if everything is working as expected. Congratulations, you have now completed the variables and Blackboards video. Make sure to check out the other tutorials and documentation available at FlowReactor.io.